Welcome back. So, as you know, this is a calculus class. So, we're not really interested in geometry for its own sake. I mean, I am, you might be, but the theme of this course is integration, finding volume, finding rates of stuff. And so, all that talk about parametric curves and tangent planes and stuff, it really needs to connect back to calculus. So here's a calculus formula. So I want to find the area of surface S over some domain D. The way I do that is I take this integral. Okay, so this integral is the norm, okay, the norm meaning the length of RU cross RV. So you compute the vector RU cross RV, and then you take the length of that vector. Right, that's what this means. Okay, this should sound familiar, right? So go back to test 1 mode, okay? Find the area of a rectangle. Find the area of a triangle. Those two things. Okay, how did we do that? Well, I said that if you had a pair of vectors, right, the area of the shape, right, is equal to the length of the cross product. So however long this is, however long that vector is, that's the area right here. Okay, so what the heck is going on? Well, basically, we are taking our curve, our surface, rather, and again, because I'm not going to show the full proof, this is an intuitive proof, not really a proof at all, but just trying to build your intuition. So the idea is you have this surface, okay, and we are going to drop a plane at a spot, but because it's dA, the domain is getting really small, right? So you're going to get a whole bunch of tangent planes, right? All these tangent planes. And what they're going to correspond to is some local region of the surface. But we're going to make these planes really small. Okay? So you're going to make these really small. And that's what the calculus does. It allows us to make things really small, right? But because we're putting tiles all over the surface, if we want to find the total surface area, we just have to find the surface area of all the little planes that we stick on there, little bitty chips, if you will, little tiles, little tiny tiles that we tile our surface with, and we let their area go to 0. But then you add it up and you get a positive value. That's just calculus. Okay, so hopefully that makes sense. But basically, the surface area of each of those is given by that, where the input at every point to RU and RV is the actual point on the domain, right? So, yeah, there are values that we're going to give that, and so this is a function of the domain D. So it varies with respect to the position on the domain. Okay, so that's all nice. Let's do an example. So the problem 40 says compute the surface area of part of the plane with the parametric equation RUV equals x coordinate equals u plus v, y coordinate equals 2 minus 3u, and z coordinate equals 1 plus u minus v, where u is varying between 0 and 2, and v is varying between -1 and 1. Okay, so this is not very difficult. Well, I'm going to put this information to the left, so I have room to write. And we're going to compute the derivative with respect to u, and then we're going to compute it with respect to b. Okay, so Ru, this is 1, and that's going to go to 0, minus 3, and 1. Okay? Rv, uv, this is going to equal 1, minus 3, and minus 1. Okay, so this is something interesting to note. It's smooth everywhere, so that's nice. That means that the tangent planes are well defined at every point. So it actually turns out that in order for you to even do this calculation, you need to have a smooth surface. So this is definition 6 on page 1157. So 1157. In fact, this is smooth at every point because this is a constant vector. And so we just have to check it once. And if we check it once, we check it for all. So let's do that calculation. So Ru cross Rv, this is going to equal ijk, 1, negative 3, 1, 1, negative 3, negative 1. And when I do that, I get 3 minus negative 3, negative 1 minus 1, and negative 3 minus negative 3. Negative 3 minus negative 3, that's 0. Because it's negative 3 plus 3. Okay, so you should get 6, 2, and 0. So that's what you should get. And of course, you do not want to scale this. Normally, when you get a tangent vector, we would rewrite that as 3, 1, 0, right? But we don't want to do that here because it's going directly into a formula, and it does matter. Okay, so what is the... don't forget to take the norm. So I'm going to add that. So add your norm around everything, right? So what is that? Well, that is the square root of 36 plus 4 plus 0. So this is the square root of 40. Okay, so we're just about finished. So I'm just going to go up to my formula, and I'm going to use these points over here, u and v, and I'm going to replace it over here. So u is going from 0 to 2, v is going from negative 1 to 1, and I just showed that's equal to the square root of 40. So this is the square root of 40 du dv, and I'll leave the rest of it as an exercise. I'll see you in the next video.